So far we have learned about the relationship between a mole and the weight, right, for the atomic masses and the molecular masses. Here we are going to learn about the relationship between a mole and the volume, how mole is related to volume. See students, when you are learning, I'll just give you a simple tip, okay, how to study. When it comes to the learning something, if you want to learn something from the depth, okay, if you want to make the roots of something strong, or if you want to make something very sure, then always try to compare. Like as you go ahead with studies, you will be introduced to new concepts. So try to find what is the similarity between the first concept and the second concept, or how this concept, new concept which you are learning is different from the other. If you try to just think over this for 5 minutes to 10 minutes, then your concept will get more clear. This is one of the way of making your learning perfect, okay, or making it more perfect. That is what I can say. So coming to this concept, the question is not a question, the concept is relationship between mole and a volume. I will write one statement. This relation is true for gases. First thing about this is that we are writing it for the gases. So one mole of any gas at STP. At STP means standard conditions of temperature and pressure. That is, temperature is 273 Kelvin and pressure is 1 atmospheric pressure. So 1 mole of any gas at standard conditions of temperature and pressure occupies 22.4 liter of volume. Any gas, irrespective of its molar mass, any gas, 1 mole of any gas occupies 22.4 liter of volume. Means, let's say, let's take an example of the methane. Methane is the gas, okay. So here it will occupy what at this condition, at standard conditions of temperature, how much volume it will occupy? It is going to occupy 22.4 liter. This is methane, whose molar mass is 16 grams per mole. Let's take ammonia, NH3. This is also going to occupy a volume of 22.4 liter if it is at a standard conditions of temperature and pressure, that is, and the molar mass is varying. If you can see here, it is 17 grams per mole. Then if you take sulfur dioxide is 1 mole of this, okay, 1 mole, I am talking with respect to 1 mole, I will write over here, 1 mole this, 1 mole this, 1 mole this, right, will occupy 22.4 liter. What is the molar mass? Sulfur is 32 and this is 32, right, here it is 64 grams per mole. Like you can see the molar mass could be varying, but volume occupied by all these gases, or you can take another example, 1 mole H2 gas, hydrogen, like this is also going to occupy 22.4 liter of volume, 22.4 liter of volume, although the molar mass of H2 is 2 grams per mole. So 1 mole of any gas, whether it is methane, ammonia, sulfur dioxide, H2, carbon dioxide, any gas, if it is in the gaseous form and it is at a standard conditions of temperature and pressure, that is 273 Kelvin and 1 atmosphere pressure, then it should occupy how much? 22.4 liter of volume. So in short, what I can say is that 1 mole of any gas, 1 mole has how much? 22.4 liter. This is the standard relationship between a mole and the volume when it comes to the gases. Okay, here is the question. Since we know the relationship between the mole and the volume for gases, like we know that 1 mole of gas, any gas, occupies 22.4 liter. Let's solve this problem. Question is, calculate the volume occupied by 32 gram of methane gas at STP, at standard conditions of temperature and pressure. This is very important. Okay, what will be a volume occupied by 32 gram of water? First thing, we should have an idea like how many moles are present, right? We know the relationship between mole and the volume, right? We don't have, we can say that 1 mole occupies 22.4 liter. So first we will find how many moles of methane gas is there. So let's calculate the number of moles. So number of moles is what? By standard formula it is weight taken, that is 32 gram. And what is the molar mass? Molar mass is of the methane is 16, right? 16, no? Methane is 16. That is carbon is equal to 12 and there are 4 hydrogens into 1 is the atomic mass of that hydrogen. So it is coming to 16. So this is the number of moles, that is 32 is the weight taken and 16 is the molar mass, right? So this cancels and I find that there is 2 moles of methane gas present, right? So I know that volume occupied by 1 mole of any gas, 1 mole of any gas is how much? Is 22.4 liter. So what is the volume? I'll put this X over here. What is the volume occupied by 2 moles? Obviously it should be twice of it. Therefore X will be is equal to what? 22.4 multiplied by 2. So which is equal to 44.8 liter. Right? So here this is the case, means you understand that how much it is 44.8 liter. Means if you take this much gram of gas, okay, there is a gas which is 32 gram of methane gas, then it will occupy 44.8 liter of volume at STP. Let's take one more question. Here is the next question. Question says that calculate the volume occupied by 4 into 10 raised to 21 molecules of methane at standard conditions of temperature and pressure. Now here what is the relation you are going to use? Do we have any direct relation for this? Like we know that 1 mole of any gas occupies 22.4 liter and we are told to find that 4 into 10 raised to 21 molecule. So 1 mole of any gas is equal to what? It occupies 22.4 liter. We have this relation, no? From this 1 mole occupies how much? 22.4 liter. Can I also say that instead of 1 mole, I can say that it is 6.023 into 10 raised to 23 molecules of any gas will occupy 22.4 liter. So here these many molecules, that is 4 into 10 raised to 21, right? 4 into 10 raised to 21 molecules will occupy how much? X liter, right? That is what I need to find. Calculate the volume occupied by 4 into 10 raised to 21 molecules of methane. So here it will be what? Therefore I will write here, therefore X will be is equal to, X would be is equal to 22.4 into 4 into 10 raised to 21 divided by 6.023 into 10 raised to power 23. How you are going to solve this? This is 2 2s are 2 3s are 3 7.3 we can consider this way, or even 7.4. Right? This is 7.4. So this will be what? This is 14.8 into 10 raised to 21, and this will go on the top, and this will be 10 raised to minus 23. So this is 14.8 into 10 raised to minus 2 liter, which is equal to 0.148 liter. So these many molecules are going to occupy how much volume? 0.148 liter. Now obviously, like 6.02 into 10 raised to 23, which is bigger number, will occupy 22.4 liter. This is still smaller. It is 4 into 10 raised to 21. So it should occupy less volume than 22.4. So it is 0.148 liter. That is the volume which it will occupy. 1 minute. I think I have made mistakes. 6 3s are 18, no? This is 3 point something. Just made a mistake. Just give me a second. Some calculation mistake I have made. Please excuse me for this. Where I was, yeah. This is 6.023, right? Approximately we can cancel this by 3.6 something, right? 3.6 it will come, and this is 3.6 into 2. How much it is? 7.2, right? 7.2 into 10 raised to 21 into 10 raised to minus 23. So this is 7.2 into 10 raised to minus 2, which is equal to 0.072 liter. Isn't it? So this is the volume of the gas, means these many molecules will occupy this much liter. Okay, now so far you have understood that what is atomic mass, what is molecular mass, what is the meaning of molar mass. You have understood that atomic mass and mass of one atom is not same. You have understood the relationship between mole and volume. So many things you have understood. But I'll tell you, students, like if you watch this video and just sit that way, like you have understood something, then this learning of this subject is like volatile. It will just go off. What I will say is that you should be solving the exercise which I give after every video. Okay, you have to solve that exercise, then only it will be perfect. Okay, you will be understanding it more. Like when you solve it, it is like you are doing it. Okay, when you do it, you get a doubt, and getting a doubt is a sign of learning. If you are not getting a doubt, then you are not learning. So after every lecture, whatever questions I give, okay, whatever questions are there in the link below, right, you have to solve that. You have to solve that and submit. Okay, that is what I recommend, and this is the most important step. See, first step is important step that you have taken to this lecture and you have completed this day 1. Okay, you have completed these videos. This is the first step. Second step towards learning is you should be solving examples on this and sending me the solutions. I will be evaluating them personally. Okay. So this is for the day. So these are the concepts and explanations for the day. Have a good day. Nice. So these are the concepts and explanation for the day. Have a nice day. Bye.